Okay, good afternoon. So we will continue today with our text analysis. Okay. So as I mentioned, the main idea behind the text analysis, or the goal now is we try to look for some representation for a piece of text. Okay. So what is the intuition we'll make use? We make use of word frequency. Okay. As I mentioned, there's two things. How do you think why some words are particularly important to describe a piece of text? First, these words need to appear a lot in your text, right? Second, these words should not appear a lot in other documents. These two intuition, I think, is pretty obvious, right? So this is a main idea behind why we can use some kind of representation to describe a text. Okay, so what is the most simple mind representation of a piece of text? Is like the one which I'm showing. You have a vocabulary list. Let's say in your mind you have 500 words. Of course, in the real world, probably you have a few thousand or even more than that. So say, hey, this is my 500 most frequent words. Then I will try to check about your text to say, for each word, how many times you appear, then I can use that as some representation for your text. Okay, this is a very simple idea, but this more or less give you the feeling how to obtain the text representation. So combine with this fact, how do you represent a piece of text, and how do you think what is the signature of a text? Combine those few ideas, we will proceed with some specific technique. Okay. So as I mentioned, now all the key here is to measure frequency. But a lot of words, they are not like a, as, is. Obviously, they do not make a text special. Okay. For those type of words, we try to remove them because we call them stop words, because they are not very useful. So basically, you get a piece of text. The first thing you do is you try to tokenize them. You try to make them into ngram. Right? Start to recall what is ngram. Ngram, we have unigram. The n here is a variable, right? N equal to 1, n equal to 2, n equal to 3. Start to ask yourself, what does that mean? So after we perform this ngram separation, we get a lot of tiny ngram. Okay, and then we remove all the stop words to say, hey, this words is not very useful. And then we are ready to count the frequency. Okay, we are ready to proceed. So the next, we will present a very specific technique called TF-RDF score. This is essentially a score which combine the two intuition I try to mention. First, you need a word to appear a lot. Second, this word should not appear a lot in other documents. Okay, so to capture the first dimension, we call term frequency, right? Just as a name, the term, how frequent each term. Then another one is called inverse document frequency. This is the second aspect. What is the inverse document frequency is try to measure how not frequent in other documents. Basically, how this to measure how this term only frequent in this one but not appear a lot in other documents. So combine these two aspects, we will get something we call TF-RDF score. Yeah, the basic idea is very simple. Let's see how do we exactly try to measure them. Yeah. So this is one of the most popular scheme used today. Let be a term. Okay, so here we define each ngram as a term. Okay, because we are changing the terminology a little bit. We have a term which here a term means ngram. Okay. So then we will also have another concept called a document. A document is like an article, a piece of text, right? Then there will be another new concept. It's called corpus. Okay, so basically, it's a collection of documents under consideration. So, for example, if we want to, let's say our goal is to find some score measure, let's say, in terms of within our Wikipedia. Okay, so then each Wikipedia article will be a document here, and the complete Wikipedia, everything in, or the article inside Wikipedia, we call the corpus. Then, if you, let's say, we take 3 gram, then basically you are non-overlapping take every time you take, let's say, word-based 3 gram to be more precise. Then each time you will take 3 words, you are moving by 1 word, take another. Then you are getting a lot of those term, right? So you have term, document, corpus. Is that concept clear? Yes, questions? Oh yeah, there's something missing here. Right. Yes. Capital D. Yeah. Appear in this document, we convert from the keynote. We didn't do the checking. Yeah. So sorry. There's a this is what I was stuck here. I was looking for the T here. Yeah. So thank you. There's a let small t be a term, because I was reading this sentence. What does that mean? Okay. Let be a term. So okay, let t be a term. We have a small capital, lowercase t to denote the term, and the lowercase d be a document. Then the capital D to denote the corpus. Okay, so we have 3 letters here. All right, so now we are ready to calculate our TF-RDF score of a particular term. So basically, the TF-RDF, you can think this is a measure, a function over T, D. You need to have a small t. You are looking for this for a particular t, and then you are considering given a d, then you have a corpus. Okay, so how does that? This actually is very simple. This is we go ahead to compute the term frequency term, then we go back to compute another RDF term, then we multiply them. Very simple. Okay, so it's like this score is completely separable. So we will, in order to compute this score, we will compute in 2 steps. So first, we will only look at the term frequency. So now let's look at how do we measure the term frequency. All right, the term frequency, typically the fraction of the terms in document D, which there's maybe something missing, but anyway, so the formula is simple. Okay, let FTD be the number of occurrence of T in D, and then you are adding this frequency over different terms, right? So this is a pretty straightforward, right? You just try to count how many within a document D, the lowercase d is a piece of document. Well, I count for a particular term how many times it appears. Okay. Then I do this for every other terms. Then I will do a summation. I will sum the total frequency, but then I will just consider the fraction of that for a particular term T. Right. So it's a kind of normalized frequency. In other words, if you want to think about that. Yes, questions? Yeah, yes, that's exactly right. Yeah. we make it looks like a very scary. It's actually as simple as that. Yeah. So for example, let's look at example here. So think about those set of words is the terms appeared in a document. All right. Sorry, those are the words in your as a vocabulary. Yeah. So all the possible words. So now we have two pieces of document. Let's look at document A. All right. Then we will try to say, hey, in this document A, I have THE appeared once, car appeared once. Then I do not have truck. I have ease. I have driven on the road, but I do not have highway. Okay. So in total, if you count, I have 7 words. Okay. Each of them appeared very boringly appeared once. So each of the term will have 1/7 term frequency for document A. Very simple, right? Just counting the frequency for that particular term. So if you, let's say, if you, then of course, this is like the raw count, but looks like a THE appeared twice. So the THE, the term itself will be 2/7. All right. I hope that is not that difficult. Yeah. So then we can repeat this for B, right? The B will repeat the same process. You just see what are the words appeared. Then you just counting the normalized frequency. That's all. Yeah. So it's very straightforward. Yeah. We will come back if you found anything which is different from what I'm talking. I will try to tell a little bit more. But otherwise, it's very straightforward. But for the inverse document property, inverse document frequency, okay, is very simple, but is a little bit not that obvious. Okay, so now let's define capital N equal to the number of documents. Usually we use this bar to denote the cardinality, to denote how many members in D. So this is N is you have a total as 1,000 document. Okay. So then I want to count the inverse document frequency of a particular term T in this corpus D. How to calculate that? I will use this way. The N here, the NT here will be the number of documents where T appears. So you have 1,000 documents. I will say the truck term is probably 10 documents contains the truck, right? So then the NT here will be 10 and the N here will be 1,000. I will use 10 divided by 1,000. Then I take a inverse. Basically, I take the inverse. Then I take the log 10. That is what will be our inverse document frequency. So first of all, why log, right? If I take away the log, this becomes trivial, right? This is like you are using total number of documents divided by the 1,000 divided by 10, right? Because if this is a words appeared a lot, then I will have a smaller number, right? Because let's say my truck appeared in all documents, then my NT will be 1,000. So 1,000 divided by 1,000, that will be 1, right? If my truck term is so unique to this document, I only appear once, then your score will be 1,000 divided by 1. You will get a large number, 1,000. So I hope that makes sense to you. Yeah. So why we do? But then why we do log? It's very simple. The log usually in machine learning, when we take a log, usually we are handling super large or super small numbers, right? I hope you see that, because when you take a log, for example, if you have a, because typically here n is a super large number. Think about Wikipedia. The n, I don't know what's n equal, probably tens of maybe is a huge number, a lot of document, right? But the NT can be small, right? If you are talking about particular very special term, let's say Python, right? The Python probably appeared maybe in 1,000 documents. But if you have 1 million document, then this guy can be a very large. But when you take a log, it will bring down to a smaller number, right? Does that make sense? You are only concerned about the power, raised to power, right? So for example, the case which I'm trying to mention, if these words appeared in every document, so I have on 1,000 document, your word truck appeared in all my 1,000 document. So this guy will be 1,000. And I appeared everywhere. I have 1,000. So I will get one. I get one, right? 1,000 divided by 1,000 be 1. Then I take a log. I become 0. As you can see, it's very nicely. If this word is not useful at all, appeared everywhere, I get 0. So I say this is very bad. So then if this become 1, if this is very unique, then before I have 1,000. This is too large, of course. Then I take a log, I become 3, become very small number. So I hope this makes sense to you, why we take a log. Okay, so now let's come back here. So now we are computing the inverse document frequency for each of the term now. So now let's see, the THE appeared in document A, appeared in document B, right? Appeared in both documents. So the N here, because in this example, N anyway will equal to 2. We only have 2 documents, A and B, right? So if I appeared in both documents, then I will have 2 divided by 2, which is 0. Then the car, it appeared only in A, but not in B. So I will have 2 divided by 1. The 2 is N, right? N divided by NT, right? The NT here is 1. So I will log 10, 2. I'll get 0.3. So you multiply, now you multiply TF multiply with your RDF to get your final score. So you multiply these two, you will get your final score. All right. So this is how we compute. Does that make sense? So the final score is you multiply these two portions. Are we okay? Okay. So now let's see some examples. Let's say we have a data set. Okay. This is basically this is our corpus. Let's think each of the sentence would be a small document. Okay. So in order to analyze, so now let's imagine each of the sentence is our piece of document. So we have a corpus contains of four documents. So the task is to analyze this piece of those texts. So first we need to filter out some obvious stop word and then determine the IFDF score of each term in each document. All right. So let's try to see what will be the obvious stop word. I guess THE, the stop word is stop word, stop word, stop words, stop word, stop words. Probably stop word, stop words, stop words. Okay, after remove this, then we arrive at something like. So now the first document only contain sky blue. The second document contains the sun bright today. Then sun, sky blue, can see shining. So this is after we filled out those stop words. Okay, so we have this those words now remaining for our corpus. So now let's compute our term frequency. Yes. Stop words is so first of all, of course, from the intuition, those words does not bring very obvious meanings like the one which I try to remove is the. But in general, when we actually use them, we will have some well-defined a piece of file. They contain the stop word for a particular language. Those are more generated based on experience, right? Yeah. Yeah. For English, then we have people agreed on some common stop words. I will show that later. In Python, if we have a library, usually you have stop words, you have some kind of language related definitions. Yeah, will be encoded there. But here is if you are asked to remove those stop words should be very obvious to you. Yeah. Yes, question. Oh, okay. Yeah. I removed the can, but probably, probably the can means able to do something. Yeah, I don't know. Yeah, I don't know. It looks like a disagree. I disagree with that. Anyway. Yeah, so you see, there's a great boundary, but the probably is not that big deal for this. Yeah. Anyway, yeah. So after we filter out some of the easy stop words, okay, then we will compute the term frequency. This is very simple. Actually, you just count how many times each word appeared in each document. Then you normalize over everything. So to make sure all your term frequency, then they can add up to 1. Yeah, so this is essentially the raw count, right? For example, this is your vocabulary list, all the words you are considering, and then this is your 4 document 1, 2, 3, 4. Then you just say in document 1 I have these 2 terms appeared. In document 2 I have these 3 appeared, and each appeared once. Like in document 4, the sun appeared twice, right? So you have 2. The rest is all 1. So now you are normalized within each document. So now first you consider the document 1, because you have 2 words, 2 terms. So each of them will be normalized by 1/2. Yeah, same thing. So you basically try to make sure over each row you add up to 1, right? The same thing, for example, for the row 4. Since this guy appeared twice, everything appeared once, right? You have 6 total occurrence. So 1/6, 1/6, 1/6, 1/6. This is 2/6. So, but if you add up them, it will give you 1. Okay. So I hope this is pretty straightforward to count term frequency. Okay. Any questions for this part? So then we will try to count the inverse term frequency, inverse document frequency. Sorry. We try to find the number of documents each word occurs, then compute formula. So first, we are doing some kind of raw count. You try to say, hey, how many documents? We have a total document n equal to 4 here, right? You have 1, 2, 3, 4. Then we will start to say, how many documents contain a particular term? So for blue, only 1, right? So we say 1. For bright, we have 1, 2, 3. So we say 3, right? And for can, 1. guess once, and so on. Yeah, for some, it appeared in document 2, document 3, document 4. So we have 3. So we say 3 documents contain this. So now this is essentially we have NT, right? So basically, how many documents contain that particular term, right? We have NT. So then we plug in into our formula is use capital N. The capital N here is equal to 4. Then capital N divided by NT, then you take a log 10. So this is essentially, for example, the first one will be N divided by NT. The NT here equal to 1. And the N here equal to 4. So this is guy equal to 4. This equal to 1. So it's 4 divided by 1. So you get this. So you will put here. So this will be the inverse document frequency for blue. All right. Are we okay with all this? So then you just multiply these two together because we have a term frequency. We have a inverse document frequency. This is basically measure the two aspects, right? The first one is say how frequent a words. So how you want to see a words appeared a lot in your document, right? This is try to measure that, and this is at the same time you also want your words only appeared in your document, but not in other document. So this is try to measure the second aspect. So then you just multiply these two together, you will get your term and the inverse document frequency. So for example, for the blue, you just multiply this guy with this, you will get this, right? 1/2 multiply 0.6, you'll get 0.3, and so on. You basically you repeat this for each of the entry inside your term frequency. All right. So this will, after you multiply this will use to rank the importance of words within documents. And most important words for each document will be highlighted. For example, in the document 1, you will see, hey, the blue is a very important document. Why? Because blue only appeared in the first piece of document and no place else. And also it has pretty okay frequency in first document. Okay. The sky appeared equal frequent in the document 1, but unfortunately it also appeared in another place. So become less important. All right. So then the blue become the keyword for the first document. Same thing here for, let's say, for the document 3, you will say, hey, this guy is very important. For document 4, these 3 guys are equal important. So now you have a very good signature or very good understanding about what are the important words for those documents. All right. Are we okay with this? So this is essentially try to say you have a document, right? You want to get what are the most significant words inside your document too, if you want to use that as your representation. All right. Any questions? So talk about, so now we have finished the theory part of how to use the formula to calculate these things. But now we want to move to how we want to in practice how to process using some Python toolbox. Okay. So we introduced this in this class. We introduced this NLTK. It's called Natural Language Processing Toolkit. So we will mostly use this library to process those documents. Okay. So the first step is to try to tokenize. We will try to break those texts into tokens, and we will show some examples using Jupyter. But essentially, either you want to break your words into each individual words, right? Like unigram, or you want to move with increase your n into some like trigram or something. Yeah. So basically, you need to split your document into a lot of pieces of small tokens, and then typically we will try to remove those non-word characters, some like a punctuation, those comma, full stop. We will try to remove them. Okay, during this tokenization stage. And we will also try to unify the case. Typically, we will try to make everything as a lowercase to make things a little bit simpler. And we also move those stop words, some kind of very common tokens. Okay. For example, if we are talking about unigram, and we have a piece of sentence like this, machine learning, it is important. As you can see here, we have a mixture of different cases, which make processing a little bit difficult, because we treat them separately or different. So what we do is we first tokenize, we try to chop them into words by word, okay? And then we try to remove some stop words, and you can ease and go, and also we try to unify those lowercase and uppercase, which makes everything to be lowercase. Okay. So after that, but there's some very interesting or very important step. As we know in English, we probably mean same things. For example, study, right? Study, you probably studying. You have a different form of the same words, right? How do we deal with that? Because they mean something, they mean different things when we try to follow those grammars. But in order to understand the piece of document, they contribute equally. Okay. So there's two techniques to unify the representation of those words. The first one is we call stem. The second is called lemmatization. The stemming is a little bit more simple method. It try to reduce just simply by truncating or reducing those words into a common stem. For example, studying, they will try to reduce to study. Okay. But this is do cause problems. Okay. I think that later we may show some examples. This by simply reduce the how to say to a common stem does not capture everything. Yeah. So a better way is to map words to their dictionary form. So for example, study is studying, we will try to reduce to a study. This is of course a much preferred way, but in order to do this, you need understanding about a language. So usually we need to have some well-defined dictionary forms aside. So some people need to create that first by understanding the language to at least know studies, studying, they are all share the same origin. Okay. So that is a require part of speech specification. Okay. Fortunately, in our toolkit, we do have this. If we want to use lemmatization, we do have this specification provided by the library. Okay. So lemmatization is more complex. We need to type in a word to get things right, but preferred when possible. Okay. For example, here give a very cute example. For example, the stamp version of important is import. Actually, they are means complete different things, right? So important, import. They mean something different. So this is a good motivation to say why lemmatization is preferred if possible. Okay. So as you can see from this NLTK, we can import the stem, also the word lemmatization. So this is some part of speech specification is provided there. All right. Any questions about the general procedure to processing the text? Okay. So what we have studied so far is a field we call natural language processing, or NLP. This is as I mentioned, this is probably one of the most active or one of the most important AI or machine learning field today. Yeah. So NLP is concerned with how automatically analyze large corpus of text. There's two main class of NLP, rule-based and statistically. TF, IDF is simple but widely used statistical technique. Today's innovation I largely in statistical category, leveraging machine learning. So as I mentioned, this is the NLP actually is super exciting. It's super exciting. For example, some of the typical applications we can think about that, machine translation, right? As I mentioned, if you are using nowadays, if you're using Google Translator or Google Translation, in the past few years, you can witness the great breakthrough in the translation. The translation is a lot of time in early days, the translation will be a kind of, you can sense the machine flavor there very strongly. You can say, hey, this is machine generated. But nowadays, if you can try, if you know two language, you can try to put a very beautiful written language in one, then translate to the other, and see how do you feel about the translation. Yeah, typically it's pretty natural. Yeah, I was very impressing. On one side, I'm also speak Chinese, and once I was very surprised when I cut some kind of Asian Chinese, I put in the translation. Actually, it pretty pick up the language, the meaning very well. So that means really they are doing some great job there. And also there's some kind of concept which fascinated me a lot is if you want to do machine translation, a lot of time you need to know English and French. You know both language you want to do, right? And then you want to translate French to another language, and looks like you need to know all the language in order to do. But then later, actually, when you really see into this domain, and more fascinating things can that they can propagate. You do not need to know all the individual language. Probably you can even make the English translate to French, French translate to Spanish, and so on. Actually, you can make the translation become like very unified tools across many languages, which is a very fascinating concept. Yeah. And also the same thing happens for the speech recognition. We all have the experience with Alexa. We are all the things from Alexa, right? How it can super accurately recognize your speech. It's not only understand your speech, but actually understand your language, right? Because a lot of time it will listen to the phonic you try to say to translate to some letters. But in order to give you the more precise sentence, actually, the Alexa or Siri really need to understand your language. They need to, I don't know whether you have this experience. I mean, if you do the live translation, when they hear more words, they will make some correction to the previous words. Yeah, if you can try later if you have the opportunity to try some kind of live translation of your speech. Once you start to speak something, there's a live translation to do that. Actually, they do correction. When they hear more context, they will make correction to the previous prediction. So what does that mean? That means they need to understand the full context. They are using the language. They're using the sentence structure. They are using just simple the phonic way to do the translation. Okay, and also the document summarization. This is actually even more than that. We are not only able to summarize document, like we have talked so far is summarization, right? You can summarize a piece of document into a few words, right? A few most important words. But we can also generate document. As I mentioned, a lot of newspaper, those are probably those are market report or some of the, actually they're machine generated nowadays. So they probably, people will proofread a little bit, but they are already pretty nice. I also saw some more fascinated people even start to say how to let the machine to write a piece of Python code, for example. Yeah. So I don't know how good is that, but it looks like a lot of potential there. So this is a so which is reason why people predict maybe with the AI some of those field, for example, the medical field, the also these those legal, those lawyers field will be affected. Is because a lot of those document understanding, document analysis, document generation. For example, when you see a doctor, the doctor is trying to busy to note your symptoms, right? A lot of time they need to do this at the input, but other things actually can be handled by machine, right? The machine just doing a very good documentation. Also, it's the same thing. A lawyer charge you a lot because they need to read a lot of previous cases. But once those things be partially helped by machine can understand and try to bring all the relevant cases. Probably the lawyer will reduce the cost, the charge to you a little bit. Yeah. So there's a huge potential for the language. I hope those examples I try to give to fascinate you a little bit, and also using your voice to communicate with robot, communicate with your car, communicate with everything. So there's a huge potential for the natural language. So which is a reason why this become a super hot field. Yeah. So I have a few more minutes. Any questions? Yeah. Or any things or any. Otherwise, I will see you next class. Yeah.